So today we're going to be finding all the real zeros of the problem, positive 3x to the 5th plus 2x to the 4th minus 3x minus 2. The first thing we're going to need to do is factor by grouping. If we wanted to, we could use the Scartouche rule of signs and the rational zero test, however it's not good. So if we factor by grouping, we have 3x to the 5th. We're going to need to put the first two factors together and the second two factors together. We're going to need to find common dividends for both. The next thing we're going to need to do to find our real factors is set them equal to 0 and solve. So if we put x to the 4th minus 1 equal to 0.
Okay.
So we're going to need to add a positive 1 and add a positive 1. Then we're going to get x to the 4th equal to 0. To solve for that part, we're going to need to use a fourth root on both sides. Except that's not 0. That's a 1. And a fourth root here as well. The fourth root is going to cross out with the fourth power, and we're going to get x. We're going to get x equal to a plus or minus 1 because we use a form of the square root, and therefore it can be either or. For this one, we're going to need to subtract 2 and subtract 2. And we're going to get 3x equal to negative 2. If we divide by 3 and divide by 3, we're going to get x equal to a negative 2/3. Next, we're going to go and we're going to do synthetic division to be able to find a simpler form to factor to find our imaginary solutions. So to start off, I'm going to use negative 1, and I'm going to use the factors of the coefficients of our original problem. So I'm going to use 4. We have no remainder. So if we put this into equation, it's 3x to the 4th, 1 power less than what we started with, minus 3 minus 1x cubed plus x squared minus x minus 2. So since this cannot factor by grouping, we're going to need to use synthetic division again. So instead this time I'm going to use negative 2/3 as my number on the outside. So in this instance, what we're going to end up with is 3x squared minus 3x cubed minus 3x squared plus 3x minus 3. So the last thing we're going to need to do to find our imaginary solutions is factor by grouping again. So if we can group the first two and the second two terms together. Again, we're going to need to do the same thing and find common factors for both portions. We're going to set 3x squared plus 3 equal to 0, and also the same thing for x minus 1. I'm going to get the easy part over with and add 1 and add 1, x equal to 1. However, this isn't significant because we found out in the beginning that it is a factor we already know. So, in order to find the imaginary solution, we're going to subtract 3 and subtract 3. They cancel. We're going to get 3x squared equal to negative 3. So we're going to divide by 3, divide by 3, cross those out, x squared equal to a negative 1. We're going to use a square root and a square root. However, we have a negative 1 on the inside, so we're going to pull out an I instead. So we're going to x equal to a plus or minus, because we use the square root, plus or minus an I. So all of our factors in total are x equal to plus or minus 1, negative 2/3, and a plus or minus I.